We're going to take a look at this question and understand how can we express h in terms of x and y. Okay, so as you can see here, we have a semicircle, and that the distance from A to B, which is like the diameter, would be x plus y, and the distance from A to D would be x, and the distance from D to B would be y, and then finally the distance from D to C would be h. So how can we approach this problem? How can we express h in terms of x and y? Well, one of the approach is that we can use we can look at this diagram and see that it's made out of 3 right triangles. Okay, and I have drawn that for you down here. If you look at this corresponding to this, and then this right triangle correspond to this one, and finally this right triangle correspond to this as a whole. Okay, and then we can express the hypotenuse by C and D and A and D as I have shown in this case, right? So we can express the longer side by 2 of their shorter sides, and that's the Pythagorean theorem, and I've written it down as you can see. So the distance from A to C, the Pythagorean theorem tells us that this distance from A to C is AC squared is equal to AD squared plus CD squared, and I have done that for each one of these right triangles. So how do we continue it? How do we continue? So the next step would be that we want to express this big right triangle right here as like the combination of these two, because as you can see, this big right triangle can be expressed as AC squared plus CB squared, which I already have expression for these two right here. So we can combine that first. So let's do that. So AB squared is equal to AD squared plus CD squared plus CD squared plus DB squared. Okay, so then you could see that this actually becomes AB squared is equal to, well, we only have 1 AD squared, right? But we have 2 CD squared. So what does that become? Well, that becomes plus 2 CD squared. Then we only have 1 DB squared, so that will just be DB squared, right? So then we can see that, well, what is AD? Let's look back to our original diagram. Okay, you can see that I have my condition listed. AD is equal to x, so let's replace that. Okay, so AB squared equals to AD is x, so this becomes x squared, and then we have CD is h. Okay, so this becomes plus 2h squared, and then finally we have DB, which is equal to y, so we have plus y squared. And then it's not hard to notice that AB, what is A to B? Well, the distance from A, B is simply x plus y, right? The distance from here to here is x plus y, right? So AB will equals to x plus y. So this will become x plus y squared equals to x squared plus 2h squared plus y squared. Okay, so next step will be to expand this. Well, this becomes x squared plus 2xy plus y squared equal to x squared plus 2h squared plus y squared. So as you can see, we can cancel the terms such as x squared and x squared, they cancel out, and then we have y squared cancel out, and then we're left 2 cancel out. So we're left with xy equals to h, which then this expression becomes h squared, I'm sorry, and this becomes square root of x times y equals to h, and that is how you express h in terms of x and y. And the curious thing about this is that this is actually the formula of geometric means, which I will talk about in my next video on the AGM inequality. So that's it for this video, and I hope you learned something.